All right, so let's take a look at this one now that you guys have had a chance to try it on your own here. What'd you come up with for U?
The second bracket.
Yeah, the stuff in this second set of parentheses. Why'd you pick that instead of this?
Because that's the one to the power.
It's raised to a power, yeah, so it's an inner function there. So we've got that 2x cubed minus 3x squared plus 1. And then what's du?
6x squared minus 3x. 6x.
Yeah, you got me going. Minus 6x dx. Okay, don't forget that dx because that's important. As you're looking at this whole thing, that's what you're substituting for. Okay, you're going to put du in for that. Of course, we don't see that yet. So what do we have to do? Okay, multiply by a 1/6 outside, and if you multiply by a 6 and distribute it to this set of parentheses on the inside, then you've got your 6x squared minus 6. Okay, is that making sense? All right, so we have this dx, okay, that is du. Okay, so there's our du. Okay, so it's 1/6.
U
So then
to
it's u
the
over
third.
6.
Good, u to the third, the integral of u to the third du.
Yay!
Okay. Okay, so Alec, what's the integral of u to the third?
Here's what I went wrong. It's one fourth u to the fourth.
Okay, it's 1/4 u to the fourth. So we have 1/6 times 1/4 u to the fourth. Okay. And then what's the last thing we do? Plug the u back in. Good. Plug the u back in and put our plus c on there. So we've got a 24 in the denominator. U is a 2x cubed minus 3x squared plus 1. And that's to the fourth power. And we've got the plus c here. Okay?
See, I forgot to take the antiderivative of u. That's fine. Thank you, Tyler.
Alright, now, I wanted to show you guys one thing from the formative that we had that I thought was really, really cool to see. So, here was from our last formative quiz, and Isabella tried the problem that I had given you, where I gave you the second derivative, I gave you a point on the first derivative, and a point on the original function, and you had to integrate and then plug in the point on the derivative to find c, the constant in the derivative. Then you had to integrate that and plug in the point on the original function to find the constant on the original function. Okay? Now, on the right-hand side is what pretty much everybody did, because we hadn't gotten to integration by u substitution yet. Okay? So, here she integrated, she FOILed it out, integrated it, okay? And she solved for, she plugged in the point 36 and solved for c and got negative 57. Alright, a lot of you guys did the same thing. So now you had the f prime equal to x cubed over 3 plus 3x squared plus 9x minus 57. Then she integrated that, plugged in the point 25, and had a little arithmetic issue there, but we would have gotten a plus 91 2/3. So our final answer would have had a plus 91 2/3 as the constant. Okay? So this is the function that we got. So she decided to also try it. I'm not sure why, but she decided to try it using u substitution as well. And she noticed that du, u would have been x plus 3, du is just 1 dx. So she integrated it as u squared. So it's u cubed over 3. So she had x plus 3 cubed over 3. Notice though, when she plugged in her point, 3, 6, she got 9 cubed over 3. You subtract that from 6, and she got the constant to be negative 66. So notice here, the difference, here's the first derivative, doing it with u substitution. Here's the first derivative, doing it the other way, okay? And it appears as though we've got a problem, because here we got a negative 66 as the constant, here we got a minus 57.
No, because once you FOIL out x plus 3, it gives you plus 9, so then you just add 9 to a negative 56, and that negative 66, and that gives you a negative 57.
Exactly. And that's where, honestly, you saw it a lot faster than I did, because I went through this and I did it both ways like 8 times to try to catch arithmetic errors or whatever, and finally, with some help, we figured out what the issue was. Because, yeah, when you expand this, the x plus 3 cubed, you get a plus 27 divided by 3 is a plus 9, okay? So right there, you're going to get a plus 9. Negative 66 plus 9 is the negative 57. Okay? So, it's a little bit... I'm sorry, what?
What do you do with the x in the parentheses?
I'm just looking at the, like, what the constant term would have been. If we expanded out x plus 3, it'd be x cubed plus 9x squared plus 27x plus 27, all over 3. And the plus 27 over 3 would be the plus 9 there. Okay, so I didn't expand the whole thing out, but there you can see here, they might look very different, but they actually are the same thing.
So before she went on to do f of x and then integrated f of x, should she have expanded?
No, she didn't need to actually, because again, she did u substitution. U is x plus 3 again, du is just dx, so she integrated it as u cubed. Alright, so that's u to the 4th over 4. So that's how she got a u to the 4th over 12 because of the 1/3 that was already there. And then the minus 66 became a minus 66x. And notice when she plugged in the 0.25, she got a constant term of 1019 over 12. Okay? But again, if you did 3 to the 4th divided by 12 plus 1019 over 12, that would equal 91 2/3. Okay? So it's
So her question of what did I do wrong on this one is nothing.
absolutely nothing. Yeah, she didn't do anything wrong. But they looked very different. And it looked as though the constants were different. But that's just kind of I thought that was a really good example just to see how, number one, you can use a variety of methods with some of these. But when you do that, your answers may look very, very different from each other. Alright, so let's use the rest of our time here to practice. Guys, this is the kind of thing that you just need to practice the process, okay? There's a couple here, in 2 and 3, 4 and 5, okay? There's a variety here. These ones here, you've got the rational functions, so you're going to be doing the integral of 1 over u, okay, which was natural log of absolute value of u, if you remember. Here you've got the trig functions, okay, which you may need to use some identities for, like with tangent. So you can work together here, but I want you working on these, okay? Don't waste this time. This is important practice. We're coming up on an assessment here pretty soon. and before we get to actually applications, okay?